Hello everyone, my name is Dr. Kunal Patel. After a long time, I am able to make this video, right? In continuation with our machine learning tutorial, today we are going to learn about the logistic regression, right? So, in my previous video, we have seen about the linear regression. So, today we are going to see what is the difference between logistic regression and linear regression and how we can solve the problem that are not able to solve with the use of linear regression with the use of logistic regression. So let's first of all introduce logistic regression. So logistic regression is a popular statistical model used for binary classification. Actually, this is the regression term is attached with this logistic, but it is actually the binary classification problem algorithm, and that is for the prediction of the types yes or no or zero or one kind of stuff, right? So most frequently used machine learning algorithm for binary classifications that translates the input into the zero and one. So suppose say for example, if I want to find the whether my email is a spam or not, right? So that can be considered under the logistic regression. Suppose for online transaction, it is a fraudulent or not. For tumor, it is a malignant or not malignant. Or for election, suppose if person is going to vote for which party, whether it is for Congress, BJP or NDA, right? So these kind of problems are considered under the logistic regressions and that can be solved by it. Now, logistic regression is the appropriate regression analysis to conduct when the dependent variable has a binary solution. So earlier we saw that binary solution means either it is a zero or one or yes or no kind of thing. Evaluate the relationship between one dependent variable, binary variable, and one or more independent variable. So in linear regression, unlike the linear regression, which outputs continuous number values, right? So logistic regression transforms its output using logistic sigmoid function. So here one new thing is there that is known as the sigmoid function. Very soon we are going to see what is the sigmoid function. Sigmoid function to return a probability value and which can be mapped to two or more discrete classes, right? So let's take one example that if we have a situation like linear regression, so it helps us to predict the student's test score on scale or grade base of 0 to 100. So linear regression predictions are continuous numbers in a range. Whereas logistic regression, it helps us to predict whether the student passed or failed. So this is the difference between linear regression and logistic regression. So here logistic regression predictions are discrete, only specific values or categories are allowed, and we can also view probability scores underlying the model's classifications. Okay, so this is the difference between linear regression and logistic regression. Now, by the visualization, if we want to find the difference between linear regression and logistic regression, so let's understand this image. Here we have two different graphs. One is this is for x, this is for y 0 to 1, right? So either your value is 0 or 1 for different values of x. So here predicted y can exceed 0 and 1 range according to your inputs, right? So here this is our best fit line. This is our best fit line. So you can see that there are lots of points are missed. Lots of points are missed in this, right? The same problem we can solve with the use of logistic regression like this. This is a sigmoid function, right? So this is a sigmoid function. So you can see over here, there is a S kind of structure. So it can accommodate a maximum number of data points. So our predicted value y lies within the 0 and 1 range. Okay, so this is the basic difference between linear regression and logistic regression. So those problems which cannot be give or solved with the use of linear regression, that can be solved with the use of logistic regression. Now, in this logistic regression, there are three main types. One is a binary, means a target value can have only two possible types. Either it is a 0 or 1, either win or loss, or pass or fail. Second type is multinomial. So target value or variable can have three or more possible types which are not ordered, right? So either if we have a example that we have collection of animals, from that we want to categorize three. So either it's a cats, either it's a dogs or sheep, right? And ordinal means target variables with order category. So for example, either it is a low, medium or high, good, poor, very good or very good, right? So these kind of uh, you can say types lies within the logistic regression. These are the different types of logistic regression. So according to your scenario, according to your situations, you can choose any of these. You can categorize any of it. Now, first is a binary logistic regression. So it is a very simplest form. Either it is a 0 or 1, right? So it is also known as a binary or binomial logistic regression. Okay, and in which the target or dependent variable can have only two possible types. It allows us to model a relationship between multiple predictor variables and binomial target variables. Suppose in case of logistic regression, the linear function is basically used as an input to another function such as g. So the following relation will be there: h of theta, h of x theta is equals to g theta transpose x, where 0 less than equal to h of theta less than equal to 1. So this is the basic function, right? Now, what is the meaning of sigmoid function? Don't worry about that function. We'll see one wonderful example with the use of logistic regression in my next video, so you will get the idea how you can solve it. In Now let's talk about sigmoid function. In order to map predicted values to probabilities, we use the sigmoid functions. So the functions maps any real value into another value between 0 and 1 only. So in machine learning, we use sigmoid to map predictions to probabilities. So very soon we'll see one example in my next video. So you will get the idea how you can calculate the value using sigmoid function and how you can predict the values. Here is the basic equation of the sigmoid function. So z is equals to 1 divided by 1 plus e raised to minus z. So z is equals to theta of x hour, right? So zz is the output between 0 and 1. That is our probability estimated. Z is equals to input to the function, your algorithm. So earlier in linear equation, we have calculated mx plus b. So that can be put instead of z, and then you can calculate the value. And e is the base of nature log, right? So it has some exponential value. So this is the sigmoid graph. So you can see over here, this is 0, 0.5 and 1. So either it falls below zero point 0.5 or it falls above zero point 0.5, right? So this way you can calculate. So how you can choose the decision boundary? So our current prediction function returns a predict probability score between 0 and 1. And in order to map this to the discrete class, whether it is a true or false, whether it is a cat or dog, we can select a threshold value and tipping point above which we can classify values into class 1 and classify values in class 2. So in previous figure we can saw that there is a 0, zero point 0.5 and 1. So if p is greater than equal to zero point 0.5, so we can say that it is a class 1. And if p less than zero point 0.5, then we can say it's a class 0, right? So this is all about the decision boundary. So you can see over here, this is our decision bound and this is our sigmoid line, sigmoid function. Okay, so the line, this is a zero point 0.5, this is a zero point 0.5. So above zero point 0.5 and below zero point 0.5. So that is a class 1, that is a class 2, right? So now let's solve one logistic regression example using Python code. So please watch my next video for the logistic regression example.